Hello and welcome back to my RC channel. I'm Andy RC and today I'm going to be talking you through a build that I have done. Now, I've been talking about this build for a while and I've been waiting for the components to turn up and everything is here and I've built it and flown it, so now I'm ready to talk you through it. Now, one of the things that interested me most about this build was the design of this frame. Now, I see a lot of talk that goes on around the internet, whether it's forums or YouTube videos, talking about what is the perfect frame for quadcopters. And I think the answer is we don't really know, and I always believe that what we really need is a Formula One team to throw a load of money at it to find out. But I don't think that's going to happen anytime soon because, well, there's not a lot of money in it at the moment. And I think this is probably the closest that we're going to get to that sort of design, because this is the FURC core, it's the V2, and it was designed and tested in a wind tunnel. And it's moulded carbon rather than being just sheets of carbon that are cut out. So the tooling for this is very expensive, and the result of that is it's a premium frame. I think it's very well priced. And you might notice as well, where's the carbon fibre weave? This is the UD carbon version, which is the strongest carbon that there is. It goes 3K, 12K and UD. The problem with UD though is it's not very pretty. It's not pretty at all. It's a bit rough around the edges, but it serves a purpose. And if you aren't into that, they do actually sell normal carbon fibre versions, but I wanted to try this out. It was something different. So it's a challenging build, this one, because as you can see, all this is one piece, and we just have these screws here for the top part, and the idea is that it's just purely for racing. You can't stick a GoPro on there, there's no room, but you can see there it looks very aerodynamic, and we've got little things like this. Can you see we've got these sort of like cutouts here, and this is actually functional. If you look at some of the control surfaces on some aerobatic aircraft, they've got these. And yeah, like I say, it's been designed in a wind tunnel, and yeah, I think that's quite a rare thing for this hobby. So other specifications, such as the motors, I'm using the 3B motors. They are the 2407 2600 kV motor. Really nice motor. We've got the hollow shaft there, and then the props, these are the Azure props, and I think they are the 5045. They've come out with some new ones here which I want to try at some point. They are the 5150, and apparently these are pretty good as well, but I just like the looks of these. Just look at that nice star pattern on there. You can always get me with aesthetics before function. Yeah, so we also have got 32-bit ESCs, and all of this is from Underground FPV. Pretty much every single part you can get. So these are the Kamikaze 35 amp 32-bit ESCs. They have got telemetry on there, and that hooks up to their own flight controller. I think it's called the Kamikaze F4X, and I've also seen it called the Omnibus F4 SD corners as well, but it's got all sorts of things like a power distribution board. It has got a isolated IMU, and it's actually covered as well, so it can't get knocked, which is quite nice. So yeah, using that flight controller, and yeah, you can actually get a 4-in-1 ESC, but I think you'd really struggle to build it up like that because everything in here is just so tight. Even with just the single board in there and the ESCs in the arms, it only just fits in there. So for the camera, this is the Caddx S1 Turbo, I think it's called. I like it. However, I'm not too keen on how the on-screen display controller fits in. There isn't enough pins for the ground, and you have to solder an extra ground in, and you'll see that a little bit later. And then the VTX is the TBS Unify, and I've got that plugged into the smart audio as well. And this video, it's kind of going to be a log of this build, because there's a lot of trial and error that I had to do, because I never worked with an F4 and smart audio, so I had to make a lot of changes. I soldered some caps on here because I thought that would help with noise, and I ended up removing them. And there's also a cap on here for the video as well. Like I say, you'll see all of that. The weight is pretty nice. It comes in at 300 grams, so extremely lightweight, and it will take up to a 6S. Now, I'm just going to fly on a 4S because, spoiler alert, it's absolutely bonkers on a 4S. I couldn't even imagine what 5 and 6S would be like, but you know, if you're into your racing, then you know, that might interest you a lot. So lastly, I'm using the XM Plus receiver. It's quite tricky where to route it, so I just got it coming back on the arms there, and that seems to work, no problems. The only thing I had to source was my own 14 gauge wire and also an XT60, but yeah, everything else pretty much was from Underground FPV, and I'll link everything in the below if you want to check that out. And let's get on to the build. So starting off with something simple, this is the XT60 connector, which I'm tinning up. I got it off eBay, and then I'm taking some 14 gauge wire, stripping that down and tinning it. I got this as a wiring kit from Flyduino if you're interested. And then I'm soldering in the positive on the XT60, that goes in on the underneath or the flat part, and then the negative. Then cutting that to length and using my own heat shrink to shrink that down, just using a candle lighter in the blue part of the flame so we don't get any carbon. Then I'm stripping the end of that down and tinning it up, ready to solder onto the flight controller / power distribution board. And then I'm going to tin up the connectors there. A lot of people love to mention how dirty my iron is, how it needs replacing. It's 2 months old. Get a life. Right, so I'm soldering in the positive and negative on the connector there, as you can see. It's an all-in-one. And at this point I've also jumped the 5 volt, and that sends 5 volt to the VTX and camera. If you don't do that, it sends out the full VBAT, which I don't want because I'm using a Unify. Next, I'm tinning up all the corners of the power distribution board, and that's where you've got like your positive, your negative, your PWM, your ground, and also the ESC telemetry, so I'll just speed that up for you. And then we're having to build this pretty much outside of the copter because it's a single body, so this is the positive and negative going in for the ESCs. I think this is 16 gauge wire. It came in the wiring kit though. Cutting that to length and stripping it as well. And then this is the PWM wire going in, and I'm cutting that to length as well, and then stripping the other end of it, and then tinning it up. And then this is another wire I'm putting in for the ESC telemetry, but I don't end up using that, but I thought I'd wire it up. And cutting that a bit longer because that solders onto the ESC. And then this is the ground that's going to go into the ESC as well. And then just cutting that to length and stripping it. And tinning it up. And then also tinning up the ground wire and the positive to go onto the ESC, and then tinning up the ESC pads, and then that's where the telemetry wire goes in, and then soldering in the negative and then the positive, and then also the negative for the signal, and the PWM wire, and then I'm going to cut the telemetry wire a bit shorter and then strip that, tin that up, and then solder that in. Quite fiddly, this one. Then of course you need to do that for all of the ESCs, which I've magically done there. Took about 2 hours, and that's the last solder connection that's going in there. Next I have installed a buzzer, and I think I got that from Banggood, and just soldering that in direct to the board because it can feed through. Next, this is the ground wire that I'm stripping, and this is going to be for the S-bus, and this is the UART3, so that's the ground that's gone in there. And again, this is from the Flyduino wiring kit. And then this is the positive. You want to make sure you do that jumper before putting the buzzer in, because it covers the pad up. And yeah, just stripping those wires, and then this is the signal going in for the S-bus, again on the UART3, and then cutting that short and stripping it. And then this is the VTX wiring harness for the Unify, just cutting the end off that and then stripping all of the wires, so the video, the smart audio, the ground and the positive. And I'm soldering in the ground here and then the positive, but eventually, I'll show you later, I actually installed a capacitor on there because I was getting a bit of noise, and that's the video going in there. And then this is the smart audio going into the UART1. Next I'm going to tin up the pads on the XM Plus. I didn't use the XSR because it's quite difficult to set up the smart telemetry on an F4 when using smart audio. So I'm just tinning up those wires there for the receiver. That's the signal going in, and then the voltage, and then the ground. Next I'm using some heat shrink, and then again a candle lighter to shrink that down. Now I'm just measuring up the camera wire, and then I am splitting all those wires there, and then that's the negative going in, and then the voltage, which is going to be 5 volt, and then the video that's going in there as well. So then I installed some low ESR capacitors and then end up removing them, so I'll explain that a bit later, so I'll just brush over that. And then this was the tricky part, feeding everything through. You want to make sure you gave yourself enough wiggle room so that you can still desolder the ESCs once it's installed if you really have to. And yeah, I suppose I could have done that first. It's a tricky build, this one, whichever way you approach it. So these are the motor wires that are feeding through the holes there. And then I'm just going to put a couple of screws in. These aren't the original screws. The original screws are too long. And I also end up putting soft mounts on there, which I'll explain a little bit later, but I just did 2 screws. These are Emax screws, funnily enough, because the 3B motors, they're designed by the original Emax designer. Then I'm taking more heat shrink, cut 4 of those up. Now I'm cutting the motor wires a bit shorter, but again giving myself enough wiggle room in case I need to, you know, mess around with them at some point. So I'm just tinning up the ends of that and the ends of the wires there, and then putting a heat shrink over the top, which I will shrink down later once everything's soldered in. And then, as best as I can, I'm soldering the motor wires in straight, and then we can alter the direction in BL Heli Suite 32, choosing my candle lighter there to shrink that down. And of course do that for all the other ESCs. I'm not going to make you watch that for all of them. And there you go. Put in a 3rd screw in there because I don't quite have enough, but I have 3 for each. And this is where I soldered in a capacitor. At this point I connected everything up, and I was getting noise through to the video without anything arming, and putting a 330 microfarads capacitor in there, clean that up just nicely. So I put that in there. And I don't like this about this Caddx camera. I borrowed the wire from the other wiring harness and put that in there, and if you look at the end of it, it's got a ground wire on it. This is for the on-screen display controller, so I fed that through underneath, and you have to solder that to another ground, otherwise the controller's not going to work. This should have just been another spare pin or something on the camera, so yeah, I'm not too impressed with that, but anyways, I got it working because, you know, this flight controller's got an on-screen display, so I need to turn off the on-screen display that comes with the camera, so I needed to plug that in, and there you go. That's soldered up. So this is a fiddly bit, and that is installing the standoffs. I decided to put them in reverse, and I've also cut the arms off the battery plate, which they recommend you do, otherwise the ESCs wouldn't really fit in, and I'm putting some nylon screws on there. You're given this nice battery strap as well, and then that just leaves me to put the nylon screws on the top of the flight controller to stop stuff moving about, and that's just the Phillips screwdriver for those to go in. And just checking that everything is nice and tight, well, as tight as it should go, because you can end up stripping nylon if you're not careful. Then I decided for extra protection, because I ended up cutting off the arms on the bottom, I put some electrical tape around here, and then this is drilling out the top part, or the canopy I guess you could say, so that the Unify can fit in there. I'm not a fan of the way this Unify connector fits whatsoever, and I ended up ruining the UFL connector. I wouldn't recommend doing this. I need to find a better way to install it. I use some of this silicone paste that takes like 24 hours to dry, but yeah, I ruined the connector. Next I'm going to build up the camera, so just 2 screws in the side there, and then also the other side, and then this fits into this little mount here, and I decided not to use the little latches so that I've got freedom of the full range of the camera, and I used separate screws there as well. They weren't quite long enough, the standard screws. And then I'm putting in some foam tape for the ESCs so they don't move around. And at this point I also removed all the capacitors as well, because I was getting noise, but it wasn't caused by any of the capacitors. It was just something I was trying, so I'll probably end up putting those back in, and more on that in a bit. And then I used some electrical tape for the antenna, and that seemed to be fine. You don't have much space for the antenna with this build. So now I'm plugging in the camera. This is the tricky bit, getting it all to squish together because there's no room. This is the connector for the Unify, and then everything's just sort of jammed in there. And then you force the top on, and then you're given these screws here. I think they're 2mm hex screws, and then the top just goes on like that. Fits quite nicely, and just checking everything is okay, and that's the majority of the build done. Simple, right? So it was a bit of a disjointed build, this one, and I don't like to do videos like that, but it really wasn't an option, because this is a frame that, you know, none of us have really had to deal with before, so I wasn't sure how stuff was going to fit in. And secondly, the flight controller is relatively unknown, so I want to thank the guys at Underground FPV for answering all of my questions regarding it. And I want to address a couple of things that happened in the build. First of all, you'll notice that I installed low ESR capacitors on the ESCs, and this was recommended from the guys at Underground FPV. And what they do is they act as a filter. You see, when we have motor braking turned on ESCs, what that does is it actually feeds voltage back through the system, and that can cause voltage spikes. So if your camera or your VTX has a very specific voltage range and all of a sudden it gets a voltage spike, it can end up blowing up your camera or your VTX or a component on the flight controller. It can also put a load of noise through the system and upset the gyro. And I'd really like to see ESCs come with low capacitors again. They used to years ago and they did away with them. I think we need them. Anyways, what happened was I installed 330 microfarad low ESR capacitors, and when I connected everything up and armed the copter, I was getting a huge amount of noise through to the video, and I really wasn't sure what was causing it. I've not seen noise happen like that before, and this was happening with a capacitor also on the VTX 5V pad as well. So I ended up removing the capacitors. I wondered whether one of them was causing a short or something like that. Anyways, that wasn't the problem. It was the frame, and this brings me back to, you know, working with stuff that I haven't worked with before. The problem was how the frame is made. See, we've got a laminate on here on the outside, but underneath there's no laminate. It is just carbon, and what was happening was some kind of ground loop was happening between the bottom of the motor and the entire frame. So what the guys recommended me do was use some electrical tape under here to stop there being contact between the carbon and the bottom of the motor. And in the end, I had these spare soft mounts, so I decided to use those, which helped because the stock screws that come with these motors, they're too long for this frame. It's only just a couple of mil here, and I couldn't use them. And these ones were a little bit too long as well, so the soft mount actually helped in the screw length here as well. There is a little protector, actually, a little plastic cover here to stop the screws hitting the back of the motor and shorting out. But yeah, it was trial and error, and I could probably stick the capacitors back in here. One thing I should mention though is they are 25V capacitors that I'm using here, which is fine for a 4S. However, if you want to use 5 and 6S, then you're going to want to use 50V capacitors, and there just isn't the room in the arms or in here to fit a 50V capacitor. So if you wanted to run 5 and 6S, I think you'd have to risk the voltage spikes and not have the capacitors in there because they just won't fit. So as it stands now, I can do that, or I can fit the capacitors back in here, which I'm probably going to do because there's still a little bit of noise that filters through to the system, and in an F4, noise isn't good in general. Another problem that I came across was the Unify connector. First of all, you want to drill the hole really low, otherwise it interferes with the camera, it gets in the way. And I ended up breaking the UFL connector, and the Unify is ruined. And that is because the Unify comes with some liquid electrical tape on the UFL connector, and of course if I want to use their mounting system here, then I have to remove the connector because I can't feed the VTX through here. And if you put this on the other side, then this connector here isn't long enough to protrude through the carbon, and your pin doesn't make contact. So I need to find a different solution, because trying to remove that electrical tape from the Unify has ruined the UFL connector, and I've checked, it's also ruined the Unify. It's running at about 6 milliwatt on full power, so that was an absolute pain. So I also connected up the telemetry wires from the ESCs to the flight controller, It turns out it's not that straightforward. You see, I couldn't get the telemetry working, first of all, and I fed that back to the guys at Underground FPV. We tried some soft serial work to switch it around. That didn't seem to work. There's a little jumper as well on the flight controller that switches between the onboard current sensor and the ESC telemetry. I had that jumpered and it still didn't work. It's not too much of a problem though, because all that you're going to get from the ESC telemetry is like the temperature of them and the onboard current sensor, and this flight controller's got its own current sensor anyway, so I'm using ADC for both, and it's not too much of an issue. But you know, if you're looking at this system, then I'm still looking for a solution to get the ESC telemetry working, and for me at the moment it's more bother than it is worth, so I haven't done that. This flight controller as well is using its own firmware that currently isn't listed in the official Betaflight list of flight controllers. You can use the Omnibus F4SD, and I used version 3.3. It was off the Jenkins server, and that was in a attempt to use 32 kilohertz, and I did a few tests with it and I couldn't get it working. It kept locking up. So I've also fed that back to the guys as well. But I did use the Karman filters with 8K and it flew superb like that. So what I'm going to do next is take you through a bit of the setup in Betaflight. Another thing that's important to note is before you put the top on, you're going to want to bind your receiver to your transmitter. Now, for the flight, I used the Taranis Plus, but as I mentioned in my previous video, I am going to switch to the X10S at some point. Okay, so here we are in the Betaflight configurator. You now have to download this independently from the GitHub. They have taken away Chrome apps, which is a shame. Anyways, I've got the quadcopter plugged into the computer via a USB cable. One thing that's good about the Core V2 is there are holes in the side so you can access the various parts on the flight control. It's something that you couldn't do on the V1. So you can see there we've got COM16 up the top there. If you're wanting to flash the latest stable version of Betaflight, then you want Omnibus F4 SD, and at the making of this video it's 3.24. Actually, if you go on unstable releases, what does that show? Yeah, still the same. I'm using version 3.30 from the Jenkins server. It's revision 521, if that interests you. Anyways, let's connect to it. One thing I should say is that if you've got the 5-volt jumper on there, it will power up your VTX and camera, so make sure you've got an antenna on there. So if we go into the ports, so we've got the serial RX for the receiver on the UART3, and then I've got my smart audio coming through here on the UART1. And if you were able to get the ESC sensor working, what we tried was to use a soft serial and remap the UART1 for using the ESC sensor, and then on the soft serial that would then become the smart audio. That didn't work. I'm not an expert on this, so I fed that back and I'm looking for a solution. Not too much of a problem because, as I say, we can use the onboard ADC of the flight controller anyway. So I've got smart audio on the UART1 and then nothing on anything else. So if we go into configuration, I've got the motor protocol set to DShot 1200. I can do that because these are 32-bit ESCs. I've got the motor idle at 6 to make sure I don't get any flips of death. This is a new thing they've added. I'm glad. Remember, I kept putting it in that command. They have been listening set small underscore angle equals 180. So if you like to use an accelerometer in angle mode, which I do for my Maidens, then you can arm it to any angle if you put 180 in there. I like that they've added that. So for the gyro update frequency and PID loop frequency, I've got 8K, 8K. And I think they are working to have this working with 32 kilohertz. I couldn't get it working. Kept locking up when I put this on here, and also when I overclocked it as well. But I'm happy with how it flies like this. Got the accelerometer turned on here. I've got the personalization set to Core V2. That's just for the on-screen display. And then down here, I've got serial base receiver for S-Bus, and then S-Bus down here as the provider. And if we scroll down here, I've got air mode permanently on-screen display turned on. I've got ESC sensor turned off because it wouldn't work. I've also got telemetry turned off as well. And then I have got anti-gravity permanently on and dynamic filters on as well. And I went in to the CLI and put the common filter commands in there. I believe they do still work for 8K, and it certainly flew nice with that on. So you're going to want to check out Joshua Bardwell's video and make sure that when you put the commands in there that you make sure that the 32 kilohertz is set to off and also the overclocking is set to off. If I turn those on for this, it locks up. Interestingly, it's not the CPU load that has a problem with. It seems to give a serial port error. So I guess there's some things to iron out with that yet. You know, we're talking development stuff there, but a lot of people are wanting to use it because, you know, it's gotten great feedback. So I've got all of this turned on here. I should probably turn off the USB thing, but look, the beeper's not going off there, and the transmitter isn't turned on, so I'm not sure what that's about. But anyway, I'm not going to worry too much about it. So that's the configuration. And if I enable expert mode, I haven't done anything with the failsafe, but we'll take a look at that. So I've got onboard ADC selected for the voltage meter and also the current meter, and I've got my minimum cell voltage at 3.3 just because I don't like the beeper going off at the top of the throttle. I've upped the maximum cell voltage to 4.4 if I ever want to use a high volt with it. I didn't need to touch any of the scaling, all that seems to be fine. Failsafe, you don't really need to touch this these days, but you do need to check it. So make sure your props are off, plug your battery in, arm it, and then turn off your transmitter and make sure that everything stops for safety. PID tuning, I am using my own PIDs here, and you'll see a line of sight flight in a bit in this video. That was done with the stock PIDs. It does fly like that, but there's a little bit of oscillation in there, so I've lowered the gains quite a lot. It seems to fly nice like this. I've got my rate at 0.8 in here, and I've not touched anything else. Going to the receiver, I've got TAER just for my Taranis, and the XM Plus doesn't have the firmware on there, but the RSSI, so I've got that disabled there. And then in the modes, I've got arming on the aux 2, and then I've got angle. That's just for safety for the Maiden, and then acro over here. I haven't got D-Shock commands set up because I prefer a beeper, and I think beeper's much better than D-Shock commands if you do line of sight. FPV guys don't agree with that, but yeah, that's how I like to have it set up. And then if we go down to OSDs, no need to go into motors because it's using D-Shocks. However, you might want to test the direction in there. And then for the on-screen display, so the camera is running in PAL. I just got it set to auto, it seems to work fine there. Got the main battery voltage, the timer for the flight time, the craft name, and the current draw and the milliamp draw, and that's about everything. I don't tend to look at the average cell voltage. I've gotten so used to this figure here. I guess if I was using 5 or 6S and I can't do the maths, I'd turn this on, but yeah, not too fussed about that. And then I got some of this turned off as well. I could probably turn more of it off if I wanted, but yeah, that's how I've got that set up. And then if we go into the CLI, I'll just type version, so you can see what I'm using. It's Omnibus F4SD. I believe they are working to have a Kamikaze branch, but for now this will work. 3.3, and I say it's revision 521 from the Jenkins server. So one thing you're going to have to do is set your motor direction, and you do that on BL-Heli32 with these Kamikaze ESCs. So make sure I disconnect from here. And I'm going to need to use the BL-Heli Suite 32, you can't use the configurator. So I'm just going to plug in a battery. Going to want to make sure that the interface is set to clean flight down there, and we've got COM16 there. I'm just going to connect to it. Make sure the props are off. If I press check on here, it should give me all of my ESCs there. And then you can individually change the direction. So if we just unselect them all, so you can see there I got 1 reversed, 2 reversed, 3 reversed, and the 4th one normal. So I mustn't have soldered it up quite correctly, but that's why we've got this here. I haven't changed anything else, but you know, you're probably going to need to change the motor direction. And of course, if you want to check the direction, you can go into the motors tab and it will do a quick reset, and then you can individually see, you know, the direction of the motor in there. And that is pretty much it for the setup. Okay, let's go for the Maiden. I'm starting off in angle mode as always, just to make sure everything's okay. And the sun's come out, which is a rare occasion this time of year. Everything seems okay. And it feels like it's got a lot of power, I have to say. Right, let's go for a quick punch. Yep. That disappears quickly. Oh, the sun's in my eyes. Everything's looking good so far. Wow. Yep. An insane amount of power is the only way to describe it. Try acro. Yep, everything seems fine. Oh, this is gonna be an absolute beast, I'm sure. Well, I'm not seeing any vibrations or twitches. Good news. It feels snappy. It feels fast. And there's loads of power to boot. This is a racing machine. And you don't want to keep your eyes off it either. Because if you do, you might be in a little bit of trouble. Look at this thing. It is a purpose-built racing machine. And it gets away from you fast on the line of sight. Beautiful. Wow. I have to say, there's something just a little bit different about this one. It's got a ton of power. Now you can't put a GoPro on it, that is for sure. But why would you want to when it flies like this and it's got all of that power? This is a pure racing machine, which is a different one for me because I'm more of a freestyle pilot. But wow, This thing is just aching to be flown fast. And line of sight, at least, is flying really nice and acro, I have to say. Oh yeah. This is handling superbly. There is just so much power in reserve. Even when I'm just blipping the throttle, it's below 50%. So on a racetrack, I think this thing would be an absolute beast. It's brutal. I like it. It's definitely been a challenging build, but I think it's paying off already. Wow. Well, it's past the line of sight test for sure. But how's it gonna perform FPV? We shall have to see. I'll bring it in for a landing and let's go and check it out. So, as I mentioned, my Unify is running at 6 milliwatts, and that shows the signal is really weak, but hopefully it'll give you a flavour of how this thing flies. But look, you see, I'm losing reception already. Yeah, there is a little bit of noise as well that's filtering through from the system. I'm definitely going to put those capacitors back on there now that I know that's not causing the noise problems. But man, this thing just flies so well. It flies like it's a heavy copter, but it's not. You know, it's just got so much power and inertia, it just cuts through the air, and I guess that's what it's designed to do. And it's definitely been worth the hassle getting it going, because, wow, yeah, it's an impressive setup. And with those Karman filters on there running at 8K, it is as smooth as butter. I was really impressed with that. Some things, though, that I want to sort out. I want to see if I can sort out the ESC telemetry as a drop of rain comes on there. Yeah, raining all the time, and my R-line batteries are absolutely spent. I use them every single day. They've probably had hundreds of cycles. I was only getting a 2-minute flight out of them. I need to replace them. And yeah, it's heavy on the amps, this one. These motors, absolutely brutal. They're fantastic. So much performance. I do wish that they didn't have a C-clip because it's muddy this time of year, and if you end up hitting the dirt, then taking the motors apart isn't so straightforward. I prefer a hex screw underneath, but it's just a small thing, I guess, and isn't going to be a problem in the summer. It just seems so far away at the moment. But yeah, I hope you enjoyed this video. It was definitely challenging at times, but it's been worth it. And I want to thank Underground FPV for sending me all this new technology, because if it wasn't for those guys, I wouldn't get a chance to check it out. And I'll put a link in the description if you want to check out those guys. They got some top-notch guys working there, believe me, and the customer service has just been fantastic. So they are a smaller company. I thoroughly recommend that you buy from these guys. And I was really impressed with the feedback that they gave me. So yeah, check those guys out. I'll put a link in the description of all the parts used as well if you're interested in that. And I'm waiting for my new Unify Pro to turn up. So as always, thanks so much for watching. Please continue to subscribe. Cheers.